Next chapter is chapter 4, modeling relationships. So here we're going to be modeling uh, the relationships among the input variables. So far, in the models that we have seen, we have assumed that each input variable is independent of all others. But that's not a realistic case. In the real world, the variables will be interrelated, correlated, or in some fashion act in a simultaneous way, either together in the same direction or in the opposite direction. So there will be relationships among the input variables, and what are the different ways in which we can handle that relationship. That's the main focus of this chapter, and we're going to be looking at several examples. The first one is where we have inputs in stages. First stage, the outcome of first stage affects how the second stage is going to um, come about, and then the second stage affects the third stage, and so on. And then we get into the 2, 3, 4, 5. Okay. These four sections deal with correlation in a direct way. Correlation can be linear correlation, which is the parametric correlation, which is also referred to as Pearson correlation. And of course, that assumes that the relationship between the variables is linear. So, in a linear fashion, if it is very highly correlated, then you have a correlation between -1 and +1, the sign giving you the direction in which they are correlated and the magnitude indicating the strength of that correlation. And then, what if there is correlation, but it is not strictly linear? If it is a nonlinear correlation, then how do you handle that? Pearson's correlation is not going to come up with a good estimate of how the two variables or more than two variables are they act together in concert or against each other. So we have what is called COPLA, and I will give a brief introduction of COPLA and then how to use COPLAs in models. So COPLA is, you can think of it as a correlation, except that it is not a linear correlation. It is more a non-linear correlation. In fact, COPLA is about coming up with joint probability distributions from individual probability distributions of the input variables. Okay? If they are all independent, then simply multiplying them together will give you the joint probability. But if they are not independent, then we need to apply COPLA to stitch all of these different probability distributions together into a single joint probability distribution that will give that can be used to simulate all these individual input variables. And then we will look at regression analysis. Regression analysis is a way of relating one variable to another. So you have x and y, then if x goes up, then y changes either in the same direction or in the opposite direction in some predictable or estimatable fashion. So that's another way of handling relationships among variables. And then how do you incorporate simulation concepts to the regression model? So that's your 6, 8, and 9. Well, 7 in between is actually the deterministic case of regression. So I will briefly go over the regression modeling in that section, and then we will discuss how to apply simulation concepts to the regression coefficients. And then finally, we'll round out the chapter with what is called envelope method. So envelope method is again another way of relating two different variables. So we come up with kind of a curve fitting for based on one input variable, we estimate the the value of the second input variable or the third input variable based on some kind of a curve, and the curves, for each possible value of one input variable, you get different curves for the second input variable from which we can estimate the second input variable. So that's called the envelope method. So we look at all of these different methods from the by looking at cases and then how to apply these concepts to those cases.